So we're going to talk about aligning project scope and quality to deliver project value. This is the week 4 of MGT 6152.21 and E1. But one thing I wanted to say before we get going is I don't know if I've communicated this, but the fact that you guys are here on a Saturday morning when you could be doing something else really is a signal of how committed you are to your education, your career. And I just want you to know that I recognize that and value it a lot. It means a lot that you're here, and it just shows that you're making a good commitment in your future. This week, though, we're going to move deeper into project performance by focusing on scope and quality. Scope and quality shape project performance by influence, alignment, usability, rework, and value delivery. So we're going to look at how scope and quality influence project performance from a managerial perspective. And we'll begin by framing it as both drivers of value delivery and then move into scope and quality and their interdependence. We'll talk about rework and trade-offs of project managers must manage under constraint. And then we'll close with a little discussion about measurement, tailoring, and practical takeaways for protecting project value. One thing that's kind of interesting take on the modern project management way of looking at things is this. You'll hear them say words like defending project value or protecting project value. And the idea is we want to have the best integrity in the project itself so that it delivers the intended results. Project scope and quality as drivers of project performance. Scope and quality determine whether project work produces usable outcomes and delivers stakeholder value. In traditional project management, success was often judged by whether the project met scope, schedule, and cost targets. From a modern perspective, this is not enough. Scope and quality matter because they determine whether the project produces results that are usable and meaningful to stakeholders and capable of the results themselves are capable of creating value. The project is, I think, as we mentioned, well, I know that I mentioned this before and I'll probably continue, is that projects can complete all the planned deliverables and still fall short if those deliverables don't meet stakeholder expectations or are not fit for purpose. And that's why project performance nowadays should be judged not only by what was produced, but how well the results, outcomes serve their intended use and continue to deliver value to stakeholders, our project teams, society in general. Scope can be a form of a system of alignment. Scope aligns stakeholder expectations and project work and acceptance of results. From a project performance perspective, scope should be understood as a system of alignment. It links together critical parts of the project, stakeholder expectation, the work the team performs, the deliverables that are produced, and the criteria used to determine whether the work is acceptable. When scope is working properly, the project team has a shared understanding of what the project is supposed to accomplish. They have that explicit understanding of what the work should accomplish, what work belongs inside the project boundary, and how success will be judged. That alignment improves execution because it reduces uncertainty and ambiguity, and it helps guide decisions and supports consistent communication. So when the scope is weak, as we haven't done our scope planning well, the project often begins to shift during execution. And stakeholders may assume different priorities, team members may interpret requirements differently, and deliverables may be produced that don't fully match the intended needs. So it loses environment. In this sense, scope is not just planning document, it's a definition exercise. It's a performance mechanism that helps the project, it keeps the project coherent as the work moves forward. In a predictive approach, this may appear through a scope statement, a work breakdown structure, and formal acceptance criteria. In adaptive settings, this may appear through some kind of backlog structure or prioritization, and the scope definition evolves. But in both cases, the purpose is to maintain alignment between the intended value and the actual work. And so this is sort of the performance perspective of looking at scope and moving it out of the planning domain a little bit. We need to translate need into deliverables and acceptance Effective scope management converts stakeholder need into clearly defined and testable outcomes. So now we build directly on the idea of scope as a system for alignment by showing how alignment is created in practice. Projects typically begin with a business need or a stakeholder request, those initiating artifacts that we talked about. But those starting points are often broad or ambiguous. The scope statement is a process of progressively refining the need into something that's actionable. So this is the beginning planning part. The first of the need is translated into requirements. Those requirements then define deliverables the project's expected to produce. And finally, those deliverables must be associated with acceptance criteria so that the team and stakeholders can clearly determine when work is complete and acceptable. Viewing this from a performance perspective, this translation process is critical. If the link between need, requirements, deliverables, and acceptance criteria is weak or incomplete, the project becomes vulnerable to misalignment, rework, and disputes over completion. So teams may deliver outputs that technically meet requirements but still fail to satisfy stakeholder expectation. So this is also where scope and quality begin to intersect. Acceptance criteria serve as a bridge between the two. They define not only what must be delivered, but also the level of quality for acceptance. That makes them a key mechanism for ensuring that deliverables are both complete and fit for purpose. Sources of scope failure. Scope problems rarely start as dramatic breakdowns. They usually emerge through unclear expectations, incomplete definition, and unmanaged change. Some of us think of scope failure as an obvious major problem like scope creep or formally a change that goes wrong. In practice, scope failure usually begins much earlier and in less visible ways. One source is stakeholder misalignment. Different stakeholders may believe the project is intended to solve different problems or prioritize different outcomes, even when those differences are not openly discussed. They create tension later when the deliverables are reviewed. The second source is weak requirements definition. Requirements may be too broad, vague, incomplete, or interpreted differently by different members of the team. When that happens, the project may appear to be progressing, but the work is built on unstable or unvalidated assumptions. The third source is weak project boundaries. If the team does not clearly understand what's included and excluded, work can begin to expand informally. And this expansion may not look serious at first, but may appear as one more feature or one more adjustment or one more stakeholder request. But over time, informal expansion creates rework, complexity, and reduced predictability of outcomes. The fourth source is unmanaged change. Change itself is not the problem. Projects need to adapt. The problem occurs when change is introduced without a disciplined approach or a disciplined impact assessment. If new work is added without evaluating its effect on schedule, quality, cost, resources, intended value, the project's performance will begin to erode. The key point is that scope failure is often less about a single event and more about a breakdown in alignment and control. And that's why strong project managers watch for early indicators rather than waiting for visible problems. So we want to make sure that we're paying attention to these little incremental changes because they have a cumulative effect, which if you think about, I like to think of it as like turbulence in water. And just a little bit of turbulence can, it amplifies over time. And before you know it, you've got the rapids and everything's out of control. Kind of one way I like to analogize it. Scope creep versus controlled change. Scope creep is unmanaged expansion, while controlled change is a deliberate adaptation aligned to value and project constraints. In project work, change is normal, requirements evolve, stakeholders learn more, risk materialize, and priorities shift. So the issue is not whether scope changes, the issue is how these changes are handled. And scope creep refers to the gradual expansion of project work without formal evaluation, clear approval, or alignment to overall project It often happens through small additions that seem harmless in isolation. One extra report, one added feature, one more stakeholder request, one refinement that was never fully assessed. Over time, these additions accumulate and begin to erode schedule reliability, budget control, team focus, and quality. However, controlled change is different. Controlled change recognizes that projects sometimes must adapt, but it requires the team to examine the implications of the proposed change before they take action. That means asking what the change affects, what value it adds, what it displaces, what risk it introduces, and how it influences schedule, cost, quality, and stakeholder expectations. From a performance perspective, controlled change is not a sign of weakness. In many cases, it's a sign of maturity. It shows that the project team can respond to challenging conditions without losing discipline. What matters is that the project manager maintains visibility, traceability, and design logic. So everything's transparent. Is essentially what I'm trying to say here is that from a performance controlled change is a transparent process that it's a sign of maturity that shows that the project team can respond to these conditions without losing their capability to perform or without losing the discipline they have to do the work. It's important in a course like this because to understand it in a course like this because project performance is not just about completing the original plan as it's exactly written. It's about preserving the value that we intended while maintaining uncertainty and responsibility for that uncertainty. Controlled change can support that, and scope creep usually undermines that transparency and undermines the project. In scope control during execution, effective scope control ensures that project work remains aligned to approved scope, value, objectives, and stakeholder expectations. So now we shift from understanding scope problems to actively managing scope during execution. Scope control is not a one-time activity. It's an ongoing process that occurs throughout the life cycle of the project. From a performance perspective, it helps us ensure that the work being performed remains aligned with what was approved and what is intended to deliver value. This requires continuous comparison between the planned scope and the actual work. And in predictive environments, this is done against the scope baseline. It's supported by tools such as the scope statement and the work breakdown structure. In adaptive environments, this comparison occurs through backlog management, prioritization, and iteration reviews. So in adaptive environments, we essentially have much shorter planning and execution cycles. And so we maintain the integrity of the scope through this backlog process. With predictive projects, we have these documents. We have the baseline we created in the work breakdown structure, which informs scheduling and everything else. And that's how we can ensure the work being performed remains aligned. Work validation is also critical. Deliverables should not simply be completed and passed forward. They should be reviewed with stakeholders to confirm that they met expectations and acceptance criteria. This helps identify misalignment early rather than allowing problems to accumulate. One of the things I think I have also mentioned in the prior sessions is that this is one of the big problems we had early on with the predictive models when the project work became much less definable, like in software development, that there was not a lot of reviewing. Once we finished planning, there wasn't a lot of reviewing with the stakeholders to confirm what the expectations were. So we wound up delivering things that expectations had changed over time. One of the reasons is because the time it took us to do things back then was like 18 months, these big long project life cycles. And the work changes, the economy changes, people change. And all of a sudden, when we got to deliver the project results, we had two different views of what should be done. And we help solve this problem through some of the more modern techniques of demos and project reviews and joint planning sessions, even carried on through into execution. We would do that kind of stuff. Part of the change control process. Change control is a key element. It's the third key element on this slide here. It's discussed in the previous slide that change is expected. However, it needs to be evaluated and improved through some structured process. And this ensures that decisions were made with full awareness of their impact on schedule, cost, quality, and value. In the predictive environment, in sort of the traditional environment, we had like project management offices or change control boards, formal steering committees, things like that, that would approve changes and allocate changes in budget and quality. And I did a project with Bell Communications Research or Bell Labs, and they had this huge change process that we had to do, and we'd have to fly up to New Jersey once a month and demonstrate what we were trying to propose our changes to them and get approval. But they had the budget authority, and that's how we could keep the project focused. And they wanted to know what we were doing. Now, in the adaptive world or agile world, the changes are discussed with the stakeholders sort of real time, and they're integrated. And we discuss that impact on this. Okay, we can do this, but it's going to be this much work, and we're not going to be able to get to it. This we can complete it in this next 2 weeks, so we can do half of it now, and we'll do the other half next time. Those types of negotiations take place in a more real-time fashion in the adaptive world, and oftentimes the stakeholder decides what the priority is, the product owner or the customer, and they decide what the priority is, and that's what the team moves forward on. So the change is there, but it's just integrated in a different way. But they're both sort of the same idea that we want to preserve the value and understand the impact of this project's intent to deliver value. From a process perspective, this aligns with activities such as validating scope and controlling scope, which are part of the monitoring, controlling, or the governance of the project. These activities are not administrative, they're essential to maintaining performance and preventing drift. So that's where our information comes from to where the project's going. Ultimately, strong scope control protects the project from gradual misalignment and preserves stakeholder confidence and supports consistent delivery of value. Quality also can be defined as fitness for purpose. Quality is defined as fitness for purpose, not just a conformance to specifications. Sort of the old way of looking at quality, especially when it comes to products, was, well, do we meet the specifications of the product? But now that we kind of extend that, do the specifications themselves define fitness for purpose? Now we introduce a critical shift in how we think about quality. In traditional settings, quality was defined as conformance to requirements, meaning that deliverables met specifications that were defined. And while that's important, it's not sufficient from a project performance perspective. Quality should be understood as fitness for purpose, but that means the deliverable must not only meet its defined requirements, but also function effectively in its intended environment to satisfy stakeholder needs. A product can meet every documented requirement and still fail if it's difficult to use, unreliable, or doesn't solve the actual problem it was intended to address. This distinction is important because it connects quality directly to value delivery. If a deliverable is not fit for purpose, it will not produce the desired outcomes, regardless of how well it conforms to specifications. This is also where quality begins to intersect more strongly with stakeholder perception. Stakeholders evaluate quality based on their experience with the deliverable, not just on whether it passed internal checks. That means project teams must think about beyond technical compliance and consider usability, performance, and context of use. From a performance perspective, poor quality introduces defect, which require rework, produce delays, and loss of confidence. Strong quality, on the other hand, supports much smoother execution, minimizes rework, and increases the likelihood that the deliverables will be accepted and used effectively. So, have any of y'all heard of the book called Zen and the Art of Motorcycle Maintenance? Have you ever read that book?
No.
It's a philosophy book, and I read it probably about every 2 years. It's one of those books that every time you read it, you get something different out of it. I've had movies like that too. But the author, Parsig is his name. I can't think of his first name offhand, but The book is told through a story that he and his son go on this motorcycle trip with some other people. And he has this view of quality from a fitness for requirements. You know, he has this motorcycle and it works well. He knows everything about it, how it works. He maintains it immaculately. But the people he was traveling with, they only view quality from how their experience on riding it. They don't care. And so they don't maintain it. And he goes into this whole philosophical thing about those different perspectives of quality and how it depends on the perspective of the stakeholder and how they view it. The modern approach nowadays is to take those two and where the engineering creates the value that experience. And so the engineering is strong, the technical stuff is strong, and it produces. So, like, think of automobiles today. The cars we have today will go 100 or 200,000 miles, and they're no problems. They work well. The technology that goes into them is perfect, but they produce a very pleasing experience now. We're back not too long ago, and I can remember it when you had a car that had 60,000 miles on it, it was a piece of junk, and they were hard to drive and they were hard to maintain. And we've improved a lot. And a lot of it has to do with this change in how we view value and how value is perceived differently from different stakeholders. And it's important, it's kind of important to understand that. And that's the message that Parsik makes in that Zen in the motorcycle maintenance book. Designing quality into the work system. This is another sort of recent development in quality. High project performance requires building quality into processes, not relying on end of process inspection. Building on the concept of quality as fitness or purpose, now we want to shift to how quality is created within project work. Quality can't be treated as something we check only at the end of process. We want to do inspections. Inspections matter, but inspections are reactive because they find problems or defects after they've already made it out of the process. And so we have a term in software development, we call it an escaped defect. That's a defect that we didn't uncover and it's made it out into the production environment. And we have the similar things with products, you know, like I mentioned with automobiles, they have these recalls. Those, when they have to do a recall and they have to do a lot of rework, those are escaped defects in the product that have made it back. And we want to minimize that because it's one, it's inefficient. It also shows that we may not have really thought through the scope. So we can't treat it as something we check at the end, but it's important that we do, especially you think about automobiles and for safety reasons and things like that. From a perspective performance, it's an expensive and inefficient process because these defects lead to rework, delay, and wasted effort. A stronger approach is to build quality into the work system from the beginning. That starts with planning standards, acceptance criteria, and methods that continues through process design, continuous review, feedback, and validation during execution. When quality is built into the process and the deliverable, it becomes more predictable. Rework is reduced and stakeholder confidence improves. It's much like I was talking about with the automobile example and Parsik's example in the Zen and the Art of Motorcycle Maintenance book, that we build the quality in and the engineering that goes into, you know, even in software, there's lots of engineering goes in that makes it real reliable and, you know, confidence in it improves over time. This is a good modern view of project scope. But we have a cost. Quality has a cost. Cost of quality has a performance impact. Investing in quality reduces rework and protects performance and improves overall project outcomes. So now we're going to build on the idea that quality should be designed into the work, but it's important to recognize that quality has a cost, but poor quality usually costs a lot more than building quality in. So the cost of quality, and there's I think talked about it a little bit when we did the overview, but there was a whole quality movement that kind of made its through out of the 70s into the 80s and on into today. And sort of the slogan back then was quality is free. And the concept is that the investment that we make into quality pays for itself in increased performance, stakeholder quality, value, all those things. The cost of quality includes the effort spent on prevention and appraisal. Prevention includes activities such as planning quality, defining standards, training team members, improving processes, designing work to reduce defects. Appraisal includes inspections, reviews, testing, and other activities used to assess whether deliverables meet expectations. These activities require time and resources, which can make them seem expensive in the short term. However, the cost of poor quality is often much greater. Poor quality produces defects, rework delays, disruption, wasted effort, sometimes loss of trust or acceptance by stakeholders. When problems are discovered late, correction becomes more expensive because the project may have to revisit completed work, retest dependent elements, and or absorbs schedule slippage. And you think about it, if a defective automobile makes it, say, out into the public, it could even have a potential harm to stakeholders, to humans. From a performance perspective, this means that quality investment is not overhead in a negative sense. It means predicting predictability, controlling waste, and improving the likelihood of successful delivery. Also, successful life cycle of the product that we produce, the value that we produce. In other words, quality costs money, but poor quality usually costs more, often in less visible ways. It's important in project settings where we have this pressure to move quickly. It can tempt teams to reduce reviews or quality checks. It may create the illusion of speed in the short term while actually increasing delays and efficiency later. Good project managers recognize that appropriate investment in quality is a performance strategy, not simply a compliance requirement. So this is one of these things when we're doing planning, we need to plan for building quality into this. And it's a performance aspect of our planning process. Quality failures in hidden work. Quality failures introduce hidden work that consumes time, increases costs, and disrupts execution. So now we're moving on forward to building on the cost of quality. It's important to understand how poor quality actually affects project performance. One of the most significant effects is the creation of hidden work. Hidden work refers to the effort that was not originally planned, but becomes necessary due to defects, errors, or quality issues. This includes rework, retesting, fixing dependables, clarifying misunderstood requirements, and addressing stakeholder dissatisfaction. One of the challenges of hidden work is it's not often visible in the original plan. The project may still appear to be progressing according to schedule, but team capacity is being consumed by unplanned corrective actions and reduces the amount of effort available for a forward progress. And this is different than scope creep. It kind of has similar appearance, in other words, that the work that we're doing keeps expanding unintentionally. But this is work that is hidden work or emerging work that comes out of the work product itself. So it's not stakeholders coming in, it's not new features coming in. This is defects, these are errors in planning, errors in technology. In many cases, the rework is not isolated. Fixing one defect may affect other parts of the system, requiring additional adjustments and further testing. This creates a ripple effect that increases complexity and may slow down delivery. I don't know if you guys have ever experienced anything like this, but I have in some of the old cars I used to drive. You have starts overheating, so you fix the water pump, right? All of a sudden now the radiator starts to leak. Well, you fix that and now a hose starts to leak. And so it has this, fixing one thing can have that type of ripple effect. From a performance perspective, this hidden work reduces predictability. Estimates become less reliable, schedules begin to slip, and the team may feel increasing pressure, even if formal metrics may have not fully reflected the problem, so they're starting to feel the stress. This is why quality should be viewed not just as a technical concern, but a driver of flow and efficiency. High quality work supports both smooth execution. Poor quality interrupts flow. It creates additional effort and reduces the project ability to deliver value consistently. So we want to be able to progress forward through the project, consistently deliver value. One of the principles that kind of came out of the Agile world is this ability to maintain a sustainable pace, that the project team should be able to work indefinitely at a sustainable pace. Poor quality erodes that sustainable pace and it generates stress, which in turn sometimes can create ripple effects, not just on the team's morale and the team's ability to perform, but also on the project itself, on its ability to perform well. And scope and quality have an interdependence on each other. Weak scope creates quality problems, and poor quality creates new scope through rework and correction. It's one of the most important ideas that we have this morning because scope and quality are often taught separately, even though they are deeply connected in real project work. So they're interconnected with each other. When scope is weak, the team may not fully understand what is actually required, which leads to incomplete deliverables, misinterpreted requirements, or results that do not meet stakeholder expectations. So in that sense, weak scope becomes a quality problem. The reverse is also true. When quality is weak, defects and failures create rework, retesting, and correction, which introduces new work that was not part of the original plan. In that sense, poor quality becomes a scope problem. Acceptance criteria are the key link between the two because they define both what must be delivered and the level of performance required for acceptance. From a performance perspective, scope and quality have to be managed together if the project's going to deliver the right results at the right level of quality. Now, in the predictive sort of traditional environment of project management, oftentimes this acceptance criteria is either documented in the scope statement itself as specific items, especially if you're doing the project under some kind of fixed budget, a fixed contract. You'll have certain things that have to be done in order to get paid. But sometimes it's not so obvious. And a good place to put this acceptance criteria is in the work breakdown structure dictionary. That's a common place to add in that we've got this work package. This is what it needs to fulfill in order to deliver value. And these are the criteria for which we know that we've accomplished what that work package is intended to accomplish. In the adaptive world, oftentimes these acceptance criteria are written as part of what they call a user story, which is the requirements definition for an agile environment. And what the user story itself doesn't document a lot of the detailed work that has to be done. It explains what the stakeholder needs and what they're expecting out of the user story. And then there's the implementation details, which are left to the team. But at the time the story is written, they document the acceptance criteria. So that user story becomes part of that backlog we talked about, that work structure for a adaptive project. And so the team, when they get ready to implement that story, they can look at that acceptance criteria and say, okay, this is what the stakeholder wants. I want a report so that I can, increase sales. All right, that communicates that, and then the criteria is going to say the report has to have X, Y, and Z, and this is what it needs to have. And so the team can take that expectation and those acceptance criteria and put together an implementation plan. And then they can demonstrate that implementation to the stakeholder, and the stakeholder can say, yeah, that's what I wanted or what I didn't want, and accept the project based on that acceptance criteria. We have both concepts are in here. And that's where that scope and quality interdependence comes in, is through those mechanisms of understanding acceptance criteria. Rework is a performance signal. Rework indicates breakdowns in scope clarity, quality processes, or execution alignment. It's often treated as something normal or expected in project work, but from a performance perspective, it should be viewed as a signal that something's not working as intended. Rework occurs when previously completed work must be revisited, corrected, or redone. Some level of iteration is expected, especially in adaptive environments, but excessive or repeated rework usually points to deeper issues. In the adaptive environments where it's not really rework, but it's where you demo something and the customer wants a change, that's different. Rework is when you've accepted that, the stakeholders signed off on it and said, hey, this is what I want. And then when it actually makes its way out into the greater environment, we find that there's something wrong with it. Same thing with the predictive work. We've completed all the work, we've accepted it, we've validated it, but for some reason it makes it out of our testing, our verification process, and we have problems with it. And one common cause is unclear or unstable scope. If requirements are not well defined or frequently reinterpreted, the team may produce outputs that later need to be corrected. In that case, rework is a symptom of scope misalignment. And that's those defects that kind of make those escape defects I talk about. Another cause is weak quality practices. And defects are not identified early, they tend to accumulate and appear later in the process. They're more expensive and disruptive to fix. And that leads to cycles of rework that slow down progress. So did a project years ago, well, back in, I won't say years ago, but did a contract with Texas Instruments, the calculator group. And we had this whole testing thing set up to test the calculators. And the one thing they decided not to do, which they normally do, is they do what they call exploratory testing. And that's essentially just trying scenarios randomly to break the product, I guess, or to find problems. And one of the problems is that when you added 0 plus 0, you would expect to get 0. But when you added 0 plus 0, you got like something like 0.1, which we didn't have that test case written in the test cases. And we would have found it probably in the exploratory testing. So we missed it. And we had to recall all of those calculators and redo them and actually took them back to the factory, pulled the chips out, put new chips in because the software was burned onto the chips themselves. So the change had to be put back in. And so again, and it also caused a lot of problems with the trust that people had in the calculators in general. So it's important that we have this. Rework is important because it consumes resources without advancing the project. So the time fixing past rework is not time spent moving forward like in the calculator case. This reduces effective capacity and makes schedules less reliable. So the changes that we had to make to fix that pulled us off of work that we needed to do and made those schedules risky because we had a really strong deadline milestone where we had this back to school date where the calculators for the schools needed to be in the stores at a certain time. And you have to back that up. So they need to be in the stores like early August in the US, which means they needed to be in the warehouse, the distribution warehouse, probably in May, which means they needed to be on a ship from the assembly line in Shenzhen, China, 90 days before that. So we're talking about early, February or maybe even January, sometimes even into December to get those things going. So when you had this rework, it put stress on that work as well and causes all kinds of problems. So rework is something that really we want to try to avoid. From a performance standpoint, rework should be monitored and analyzed and not ignored. So you want to look at how much that is increasing. It provides some insight into where the project system is breaking down, whether in requirements, clarity, process design, communication, or the validation practice. We need to treat rework as a diagnostic information and use it to improve how the project operates and not just something that happens. The level of rework, it's exactly kind of like the level of change. Both of those are predictors of how the project is performing over time. Trade-offs in scope, quality, and schedule. Project managers must make informed trade-offs to protect value when competing demands arrive. In real projects, scope, quality, and schedule are rarely perfectly aligned. Instead, we're consistently balancing these competing demands. If scope expands but time and resources remain fixed, the team's forced to either work faster or reduce quality. And that often leads to defects, rework, and reduced performance. If schedule is compressed without adjusting scope, quality tends to suffer because there's less time for validation, testing, and refinement. Reducing quality might appear to improve the speed of the project in the short term, but it often reduces usability, stakeholder satisfaction, and ultimately undermines the value of the project. From a performance perspective, the key is not to avoid trade-offs. They're inevitable. We can't avoid them. The key is to make them deliberately and transparently. That means understanding the impact of each decision on value delivery, risk, exposure, and overall performance. We should ask questions such as, what value does this change add? What risk does it introduce? What constraints are we affecting? And what are we willing to sacrifice that and what must be protected? Ultimately, this is where leadership, judgment, and experience come into play. Managing trade-offs effectively is one of the defining capabilities of a high-performing project manager to understand how this works. In the adaptive environment, these constraints, this picture on the screen here is really an example of what we would call the triple constraints in the traditional environment. The adaptive world still have these constraints, but they kind of flip it. The schedule and the scope becomes the part that's much more adaptive. In other words, we meet with the stakeholders and they're basically setting the priority on what scope gets done. And then we're trying to get the scope done within the allowed budget and time that we have. And then we can continue, it can continue on as additional scope gets approved. Where with a predictive project, we may have a boundary on, like in my calculator example, we had a deadline we had to meet. So it affects that. So in our case, the schedule was sort of the main constraint. So every project is going to have its main, if quality is the main, so say you're working on a medical device that has to be, Six Sigma, like 99.9% effective. No, like a 0.5 failure rate is all that's acceptable. That's a quality constraint. In the calculator constraint was the schedule. In developing software, it might be the scope of the features that have to. And understanding how rework and change affects those is important. And bringing transparency to that to the team and the stakeholders is an important way to manage that. So we can do this by tailoring scope and quality by the delivery approaches that I've been talking about. Different delivery approaches require different methods for managing scope and quality and maintain performance. They should be managed in ways that fit the delivery approach. Not all projects operate under the same level of uncertainty, complexity, or stakeholder volatility. So the same methods should not be applied mechanically in every case. In predictive approaches, scope is usually defined and managed through baselines, formal change control, and structured testing. In adaptive environments, scope evolves over time through backlog refinement. Backlog refinement with the product representatives. Sometimes it could be a proxy, like a internal product manager that's a proxy for the external customer, or it could be the actual customer themselves that you're doing this refinement with. But we do the backlog refinement, iterative development, and frequent validation with stakeholders. This is that frequent iterative demonstration that I've been talking about. Hybrid approaches will contain both, using tighter control where needed and more flexibility where uncertainty is higher. So that hybrid gives us a little bit of flexibility there. And as I've mentioned before, this is where I personally think that we're kind of moving to a pure hybrid or pure context based. I like to call it, instead of hybrid, I'd like to use context method, where we're designing the approach based on the control and the flexibility that we need and the uncertainty that's in the project. From a performance perspective, tailoring matters because rigid control in uncertain environments can slow progress, while too much flexibility in stable environments can reduce discipline and predictability. So we have to balance, going back to the trade-offs. We need to adapt our scope and the quality practices to the needs of the project rather than forcing every project into the same models, which is kind of the approach we had till the modern times. Organizations would say we have to have a standard project management methodology. And usually they were very, when I was at American Airlines, we had what they call the AASDL, American Airlines Software Development Lifecycle Model. And it was how software was going to be produced at American Airlines. And it was probably 50 pages thick of stuff. And what they tried to do is they tried to funnel every project into that lifecycle, no matter how small or how complex. In some cases, it was way too much. In other cases, it was not enough. And what we did in my company, the company was called Valtech. We came in and we did one of the first hybrid projects, and we were able to deliver that project under budget, ahead of schedule, with no defects reported during the warranty period. Usually, when you deploy software, even internally, there's a 90-day or so warranty period where any kind of defect that gets reported, the core team is responsible for fixing that. And we've kind of moved from that into the more adaptive world where the team stays together. These long-lived teams, they stay together and they maintain that responsibility even past the warranty period. But we were in a transition phase. The interesting part of that is I came back to American Airlines about 5 years later. This was the AA.com, the website. I came back about 5 years later, and they had completely moved to a hybrid adaptive model using Scrum as a framework, an Agile framework underneath all that stuff. So they had taken that one project from the success of that and moved it. And the biggest difference we did is that we set it up where we had one thing that happened when we first got there, the main product owner said that every time we get a product, it's different than what we said we wanted. Usually it was small things, not big things, but small things that irritated him. So we sat down and said, okay, every 2 weeks, we're going to show you the work that we've done. And one little thing that we had is that on the user interface screen, there was the up back at this time, everybody's trying to emulate the way Amazon.com did things. And Amazon at the time used tabs, looked like file folders on the top of the page. And they had like Amazon had little rounded corners on all theirs. Well, when we demoed it, we had little square corners on them. And there was this big discussion, and it turned into a big problem. And really, when we sat down and looked at the root causes, that the software that we used to develop that page didn't have the functionality to create those rounded corners. So they had to be images that we could place on the screen. And then we had to get the images from the people that did the graphics. And once we connected those together, we were able to put the rounded corners on the screen, and the stakeholder was delighted from that. And so we were able to take that one quality scope improvement, looking at those two together, and over time, it basically transformed the way that they did business. So that's the kind of effect that this looking at the delivery approach can have on the outcome of what we're doing. But we need to measure scope and quality performance. So effective measurement helps project managers detect drift, evaluate quality, and make better performance decisions. So effective management of scope and quality depends on more than defining them well at the beginning. It also requires ongoing measurement. Without measurement, project managers are forced to rely on assumptions, anecdotal feedback, or late stage surprises. Scope performance can be measured by examining how stable the scope remains over time. So we want to measure how frequently changes are introduced, whether deliverables are being accepted as planned, or whether completed work remains aligned with stakeholder expectations. Quality performance can be measured through indicators such as defect rates, rework levels, test results, conformance to acceptance criteria, and frequency of corrections. And I can't tell you how many projects I've been on where we didn't do much of this. This was not, is one of these things that the team oftentimes feels like, well, this is just information for information's sake, and it's bureaucracy, and we have work to do, and we don't want to worry about this stuff. The problem with that kind of approach is that this tends to build over time until eventually you're so far away from what you intended to do that you're not going to be able to make it up, and the project fails. And so by paying attention to our alignment, whether it's adaptive or predictive model, but each of those have different ways to do it. And we have all kinds of tools now that track all this stuff for us and show it in, create information radiators that we can view and see. We can push information out to people. But the whole idea is to be transparent enough, or completely transparent, basically, so that someone somewhere, a stakeholder, maybe somebody will say, hey, what about this? Well, maybe it's something we overlooked. Maybe it's something we need to pay attention to. And by looking at these trends, we can look at the quality of our work and see how it's going over time. From a performance perspective, measurement should do more than document the current state, where I'm going with this. It should help the project team detect emerging problems early enough to respond to those problems. And that means that metrics should not be limited to what's already gone wrong, but they should also help identify signs of drift, instability, or weakening control. This is why useful metrics are tied to decisions and action. A measure is valuable when it helps the team decide whether to continue, adjust, investigate, or intervene. If metrics are simply generate reports without influencing action, they contribute to actual performance management. Now, in the quality management processes, you'll see in the PMIA documentation, in the process guides, the practice group, and also in PMBOK 8, there's a lot of quality control tools. There's like tornado diagrams, there's control reports. The control reports are interesting because they have you set an upper and lower limit. So maybe you've got that everything has to be 100%, or maybe we'll accept 90% defects or something like that. And as long as you stay within that control area, you can say, well, the project's under control. But you can also see that all of a sudden, most of the observations are above the mean, above the average. Maybe we have four. I think there's something called the rule of four, the rule of six. And you get you start seeing these trends above average. Well, you know that the project is tending towards out of control process, and the same thing going down. So we can use these control documents to kind of forecast what's going on from a budget perspective. We've got earned value, and we'll talk about budgets later on, but earned value gives us a mechanism to forecast if things stay the same, how much out of budget are we going to be? We're going to be over, under, what is that variance? We can do this kind of forecasting. And the quality tools that we have allow us to do the same thing. We can take these metrics, and metrics is the definition of what we're going to measure. And then once we measure it, we can use these tools to show this in a way to understand it and be able to predict what's going on. So we use the measurement tool not just to monitor results, but we also use it to improve our learning. We want to support transparency. We want to maintain alignment between scope, quality, and value delivery. Leading indicators, there's leading and lagging indicators. Effective performance management uses both leading and lagging indicators. Leading indicators help detect problems early, while lagging indicators confirm that after the effect. So measurement becomes significantly more powerful when we distinguish between leading and lagging indicators. Lagging indicators are what we're most familiar with. These produce things like defects, counts, rework levels, schedule variance, and acceptance rates. They tell us that what's already happened. They're important, but they're reactive. By the time a lagging indicator shows a problem, the issue's already affected the project. In other words, the damage is done. Leading indicators are different. They provide early signals that something might go wrong. For example, increasing requirement volatility. We start seeing lots of changes in requirement. Lots of churn in the backlog. Things are coming and going off of the backlog if we're in the adaptive world. Delayed reviews. So we're not doing our product reviews or our product quality reviews. And reduced stakeholder engagement. All of a sudden, stakeholders kind of vanish, ghost your project a little bit. They all indicate that scope or quality problems are developing. These are indicators. These indicators don't guarantee failure, but they highlight areas that might require attention. From a performance perspective, relying only on lagging indicators limits the project manager's ability to respond proactively. It often results in corrective action occurring after the damage has already been done. In contrast, leading indicators allow earlier intervention, which is usually less disruptive and more effective. So, as I mentioned in the control chart, as we see the trend, that's a leading indicator. That trend is telling us that something's going on that we need to look into. And if we waited till we broke over that out of control process where things were breaking down, then that takes like significant reaction to fix that. Where if we look at it while it's still in control, we may be able to implement a change or an approach that's going to keep us and maybe reverse the trend to where we want to be kind of random around that average when we're doing our measurements. The most effective approach, though, is to use both leading and lagging indicators to help us manage our project. Leading indicators help anticipate and prevent problems, while lagging indicators confirm results and validate whether corrective actions were successful. So lagging indicators can be positive if they validate what we expected the results to be. We should actively monitor both types of indicators and use them together to maintain control, improve predictability, and support better decision making throughout the project. So, some of the takeaways here in conclusion: effective performance depends on maintaining scope alignment, building quality into the work, and making deliberate trade-off decisions. So, brings all this together at a managerial level. Scope and quality are not isolated technical topics. There are two of the most important levers that project managers use to protect project performance and value delivery. And this project performance and value delivery has kind of two threads in our projects. We've got the performance of the project itself. In other words, how well are we executing the plans? How well are we delivering value? That all has to do with sort of the quality of the project management process itself. Then we've got quality of the actual product or the value that we're delivering. So, what is the value of our widget that we're producing or the change that we're making? What's the quality of that? So, we've really got two trends of quality. Most of the time, when we're planning quality, we're going to have an organizational level, like quality expectations through the culture of the company. Like almost everybody can agree that, Apple has its quality, culture. The culture of what they do is part of the quality is part of their culture. Many organizations nowadays, that's the way it works. But we want to adapt that to fit our project at both the process level and at the product level. Clear scope helps the team in working on the right things. It creates alignment among stakeholder expectations, requirements, deliverables, and acceptance of result. Strong quality practices help ensure those results are usable, reliable, and fit for purpose. And these reduce defects, rework, and confusions and performance drift. So good scope and good scope quality helps reduce that performance drift. Measurement is essential. Project managers need visibility into both current and emerging warning signs so that they can intervene before issues become larger disruptions. That's why leading and lagging indicators, and really why we need those, they both matter. Finally, project work always involves trade-offs. Scope, quality, schedule, pressures rarely remain in perfect balance. So we don't avoid making trade-offs. We manage these trade-offs deliberately and transparently with attention to value, risk, and stakeholder impact. So the broader takeaway from today is that project performance is strongest when project managers maintain alignment, build quality into the work system, measure intelligently, and respond to change with discipline and transparency rather than just reacting to change. And so that is the end of the show. The knowledge and skills that are covered in this course, I hope that they support your ability to deliver value in managing real projects. And those of you that are working on projects, and those of you that are kind of new to this world, my trust is that they'll be beneficial to you in the future. Your presence here is valued, and y'all have a good week. I will see y'all. I'll see some of you in person, and I'll see the rest of you online next Saturday morning. All right. And everybody those of you that observe Passover, Passover's done, but Easter, have a nice Easter Sunday.